that evolved to feed exclusively on blood. It's the only mammal in the animal kingdom that we know of that is exclusively hematophic, meaning that it only consumes blood. Now, the blood meal for the vampire bat is around 20 milliliters. And thinking about how many creatures it would take to drain all of your blood because of the One Punch Man episode this week, and also because it's Spooktober, I think. How many vampire bats would it take to fully drain your blood? Well, the average person has around 5 liters of blood in them, which means it would take around 250 baits. But it would only take 100 if you wanted to drain about 40% of a person's blood, which would send them into stage 4 of shock and death shortly thereafter. Now, this value is about the same as it is for a large leech. What would you rather be bit by? I know my answer. Tell me your answer in the chat. Oh, these can also gallop. Hello, and welcome to another edition of Because Science Live, the live part of this channel where I take all of your comments, questions, and corrections and comments about my face and body and address them directly off the top of my head. I try my best to be super nerds just like all of you. Sometimes I will have no idea what you're talking about and I'll get things wrong, but hopefully through the process of science, we can all just get a little bit smarter. Every week, not every day. That's already a channel. I have occasional voice of the void, Nate here. Nate.
Yep.
Nate.
I'm here.
Nate.
Yep.
It's dark in here. Why is it always so dark? What do we got?
All right, from Alan Forsent.
Ooh. Oh, I've heard of you before. I mean, on the channel, not stalking wise.
Moving on.
Yep.
How do scientists measure, for example, weight/mass of something as large as the Earth?
Uh-oh. I don't know. I don't know off the top of my head how do you get the accurate value for the Earth's mass without being able to put it on a scale, right? Because you can't put something like the Earth on a scale because then it's not under gravitational influence, and you can't have weight. You can measure mass of things. I'm guessing, I don't want to guess, actually. I think they infer it from probably the size, the volume of the Earth and what it's basically made out of. Taking an average density, it's not the same density all the way through, and you can measure and you can estimate the size of the circumference and the size of the Earth and the volume of the Earth, therefore, and they multiply that by the average density based on your sampling, and then you can get a general value of 6 times 10 to the 24th kilograms, I believe is the mass of the planet, but I don't know how you get that analytically. So if you know in the, there's got to be, it's probably some astrophysical relation or something like that based on like the wobbles of stuff. So if you know the actual way that astronomers do it, let us know in the chat. What's next? God, starting off feeling dumb. Can only go up from here or down, whichever direction I'm at. What's next?
Next one's good.
Okay.
From Noni Baloney. Hey Kyle, amazing show.
Yeah.
How many voices do you have in your repertoire? Do you have any favorites?
Oh, you know that I like to. I love doing voices. My favorite right now, I think. Well, I can do a screen accurate Gollum. I'll say that. My best one is probably Gollum. And through Gollum, you can do my current favorite, which is a meatwad. And meatwad is a similar process of kind of closing your throat off a little bit and getting into a higher register. So if you've seen Aqua Teen Hunger Force, it's
Oh, come on, fella. You know I don't want to go down there. Just make me turn the TV off. I just have one of my puppets here. We just sitting around, just being cool. But I don't want to go outside again with Carl because he smells bad.
So something like that. That's my current favorite one. I like to try to mix them up as well. Like try to do an Arnold Schwarzenegger with a Christopher Walken. It's kind of hard to do. I don't know. Anyway, what's next?
From Inversion Games. Can you split an arrow in half with another arrow just like in movies?
So I think what was happening, if you're referring to the Robin Hood with the Robin Hood movie with the young and so handsome Cary Elwes. I don't know how to pronounce his last name. I really don't. I think what they did is a little bit of movie magic where they have a pre-split piece of bamboo. And with a bamboo is kind of hollow, it has sections to it. And so when you send another arrow at it, the arrow, a solid arrow, if it's perfectly shot, you still need a good archer, you can split it along the seams, kind of, and it'll look like it goes in half. And I think they covered this in an episode of Mythbusters as well, but because of how, like wood is, not bamboo wood, but like a tree's wood that you make an arrow out of. The difference here is having something that's kind of hollow versus having a cross-section of wood that has many, many plant cells and fibers, let's just say, all running along this way. So if you're looking into my void here, you're trying to go through this part of the shaft. So if you do that, there's a lot of places where the arrow can kind of veer off and take just one of these splits and split off like you were trying to pick a pathway through a crowded room or something like that. There's a lot of potential diversion points for your arrow tip, which is very, very pointy, obviously. So it's very difficult, if next to impossible, to split a true wooden arrow. That's why they use movie magic for it. So I'll defer to the Mythbusters on this one. In their testing, they came close to splitting an arrow, but they could only split it so far because it would catch one of these grains in the wood and then it would split off. It wouldn't go all the way down. I think you need movie trickery if you want to go tip to tail. Sure. What's next?
From Jester Pie. Why does my carton of milk inflate when I leave it out?
What? What? Why does your what inflate?
Why does my carton of milk inflate?
Why does your carton of milk inflate? Okay, yes. So the first time I realized this, I was also sitting on a plane, and my bottle of water, which I had brought from the ground, but it was sealed, when it was on the plane, it didn't look any different. And then I opened it up on the plane. And then I opened it up on the plane and closed it again. And then when I got back to the ground and I landed, my water bottle was actually crushed. And this is because the pressures that they use in an airplane are not exactly atmospheric pressure. So let's say that your carton of milk, this is not a carton of milk, but I was thinking about my water bottle. Let's say your carton of milk was probably made on the ground. I'm going to go ahead and say that there's a 100% chance that your carton of milk was bottled at the ground. This is at atmospheric pressure, which is 14.7 psi. PSI. Inside of a plane, they don't, you can still keep humans alive and comfortable at a pressure that is a little bit lower than that. I think off the top of my head, I could be wrong on this, but I believe airplanes are pressurized at 8 to 10 psi, and then humans are still fine, and you don't have any adverse effects, and you can, anyway, you want to keep your passengers happy. So you can see that there is some discrepancy here. So if there's more pressure inside of the bottle, that air pressure is going to be pushing on the outsides of the bottle, and you normally don't see any effects from that because this is atmospheric pressure and you're normally at sea level, or you're normally under 14.7 psi or thereabouts, so you don't see anything. But if you go up into an airplane and they pressurize it only 8 to 10 psi in a closed cabin, then these arrows are going to push more against the outside of the bottle than the air around it will push back. So it's not going to be equal anymore. So it will act to inflate a little bit because it's pushing out more like a balloon. On the other hand, what happened to me is that I opened it on the plane and then closed it and got to the ground. So I opened it at 8 to 10 psi, closed it, and then when I got back to Earth, or got back to the surface, suddenly when the airplane doors opened, it was 14.7 psi pressing against 8, and so it crumpled because it was just plastic, and it wasn't a very sturdy vessel, so it crumpled and it looked weird, and you open it and it goes because air rushes in to fill that pressure differential. So your carton of milk inflates because airplanes are not pressurized to true atmospheric pressure as you know it every day. There's a difference there, and that leads to either inflation or deflation or crushing or decrushing. What's next?
From Mr. Big Evil.
Oh, big words.
Is it possible to fully drain someone of all their blood and then decapitate them without spilling a drop?
Hey, you okay, man? Wow. Can you drain someone of blood and then decapitate them so that blood isn't flowing? I'm guessing that if someone is drained of all of their blood, that if you cut off a limb, there's no blood flowing. So, in theory, yes, you murderer. But I think someone just told me this in a comment somewhere. I think it was a comment on the One Punch Man video where they saw a documentary of a man who either lost so much blood or was dehydrated. Maybe he lost so much blood that because of his, he wanted to be ritually buried, or he wanted people to find him in a certain way. Anyway, he cut his wrists. And when he did that, he said that no blood came out. Like his blood pressure was so low, or he had so little blood that it actually didn't come out when he cut on himself. So, yeah, I think there's some truth to what you're saying. But also, don't say anything that you just said to me in public. Trust me. What's next?
From Terrell Ghoul.
Ooh.
Hey, Kyle.
I like all the spoopy names.
How smart is an ant colony collectively?
Like IQ-wise? If you can think of an IQ test that you can get a bunch of ants to take, be my guest and win a Nobel Prize. No, we cannot test insect intelligence in the same way we test human intelligence because they can't take the same tests. So it would be very hard to compare them. But what you are getting at is absolutely true and fascinates me about ants and bees and other organisms that work together as a collective. And it's a distributed intelligence, kind of like an intelligence of the crowds. So you've heard of intelligence of the crowds, wisdom of the crowds. That's what I'm trying to get at. Geez, where someone says, how many, red and yellow and orange M&Ms or what have you, or coins, are in this jar. And some people, and so no one is probably going to have an accurate guess, like right on the money, within 5 or whatever. But for whatever reason, if you ask 100 students or 100 people or what have you, when you average out all of the values, it comes really close, closer than one person can come to the right answer. So that's the wisdom of the crowds. And I think the theory is that on average, most people won't give something that's too far from a good guess and too far on either extreme from a good guess. So either way too few or way too many. So if you saw a jar full of pennies, you know it's not 1 penny, and you know it's probably not 1,000,000 pennies. So if you ask enough people, they kind of narrow down their own guesses, and if you average them all out, it comes within an order of magnitude, or at least close. That's the wisdom of the crowds. Ants and bees and other insects that work collectively exhibit something similar, where if you took one ant and you plucked it out of its nest? Mound. Colony. If you pick one ant out of its colony, it acts kind of dumb. It just, might just go in circles or whatever, looking for a sick leaf. But if you have millions of ants working together collectively, some intelligence emerges. Now, I think I have to correct myself. It's not collective intelligence. I think it's emergent intelligence. So if you get enough ants together, some kind of intelligence emerges. Like the entire colony can farm fungus, which happens, but a single ant can't, and make decisions, and bees can choose where a new colony is, but only by going back to each other and wiggling their butts and dancing, and they come to a consensus where I think they upvote and downvote each other by headbutting each other after they dance, which I suggest is the new way Reddit should work. You have to do a dance, and then you get headbutted or not. So ants and bees and other insects like that have an emergent intelligence, which is really, really cool. But how do you measure that? I do not know. If there is a measure for that intelligence, it's probably in some research paper somewhere that you'd have to look up. I don't think there's a well-established insect intelligence scale that could scale to humans. It's a different kind of thinking. We humans, because of our big brains, we think of ourselves as individuals, and I's and U's, even though it doesn't exist really, I's and U's, so we don't have the same kind of thing happening. So you can test individual IQs, intelligence quotients, whereas you couldn't test an individual ant's intelligence quotient, I don't think, because they work together in a smart way. I think that's all of a roundabout way of saying, I don't know. What's next?
From P.R. Shah.
I have a friend who's an entomologist, but he wouldn't know. Taking shots at random people. What?
From P.R. Shah.
Yeah.
How do scientists know stuff about quantum mechanics?
How do scientists know stuff about quantum mechanics? Well, a lot of it is, quantum mechanics is, I think, just to the layman, the most confusing thing, probably. And I will not lie to you. It is incredibly confusing. I do not understand it. I didn't take a class in quantum mechanics. It's really, really confusing and counterintuitive because the way quantum mechanics works is kind of against all of our everyday experience. Our everyday experience is more Newtonian, if you will. Things moving not too fast, things that are not too small, doing things that act in a way that we understand it. But quantum mechanics, you can have things superimposed in all possible positions. You can have things teleporting and tunneling and doing all these weird things. So how do scientists start understanding quantum mechanics? Now, I'm not the best person to give an introductory lecture, but I would guess that it has a lot to do with experiments. One of the most famous quantum mechanical experiments is called the double slit experiment, where once we figured out how to fire individual photons and electrons and stuff, like electron guns and stuff, at, say, an experimental setup like a double slit, then we looked at what happened when what came out after they passed through the slit and hit the back of a wall, and we measured it. And it didn't look like, sometimes it looked like particles, and sometimes it looked like a wave of particle. Like if you added up everything that was happening, all the little impact points, it looked like what a wave would do. But we were shooting little particles, right? So this started hinting at that there's a grander and more subtle natural order to things, and this gets at what quantum mechanics tries to explain. A lot of it is mathematical as well. Obviously, you can't see a lot of quantum mechanical effects. There's very little that present themselves at our macro scale. One is you can look up quantum locking, which is a really cool way to use magnetic fields to suspend superconducting materials above them, and they can float around tracks and impress kids at science fairs. Another one is magnetism. Any permanent magnet has enough of its particles oriented in such a way that the quantum mechanical effect is amplified to the point where we see the true nature of the universe interacting with stuff, which is particles and fields. But if you had all enough particles synced up, so to speak, in a permanent magnet, you can get, what magnets do. So that's one of the coolest ways to look at what quantum mechanics is doing. But how scientists understand about it, it's a lot of mathematics, it's a lot of experiments, it's a lot of high energy physics, particle accelerators, lasers, all that kind of stuff. But for an intro, I am not the best person, and I do not know what the fundamentals are. I know double slit experiment and those kind of things are involved, but I would recommend the Feynman lectures. I think he gets into quantum mechanics in that, and they're all free and they're all online, and he is a legit genius, or he was. He was an incredible science communicator as well. So I checked that out. I don't know. I know it has a lot to do with experiments and stuff and mathematics. Man, these are hard. What's next? Dang!
It only gets harder.
Oh, great, cool.
From John Eofor.
Okay, John.
How far from the solar system would you have to be to experience real zero gravity?
What? Oh, no, I mean, So, how should we tackle this? Is there such a thing as zero gravity? I would say no. because of, let's say, if you take say Newton's law of universal gravitation, which I know off the top of my head as force is equal to the gravitational constant times the two masses in question, times the radius, or the distance between them, squared? Yes? Dang it. Anyway, what this implies, whether this is squared or not, can someone look up if it's squared or not? Whether this is squared or not, there's always a distance value between two objects, right? It doesn't matter if this goes to 1 foot or 1 light year. This implies that no matter how far two things are apart, they will always be pulling on each other with some kind of gravitational force. I put that in quotes because Einstein says it's more of the curvature of space and not a real pulling on objects like that. They're just following the curvature of space according with their mass. Anyway. Oh, this is correct. Thank you again. I won't fail you. So everything in the universe is always pulling on everything else everywhere at all times. It's just that these distances can get so great that the effect is more or less negligible. So the amount that even the moon is pulling on me from its distance, which is 384,000 kilometers away, 384,400 kilometers away, that's enough that the gravitational influence on the moon on you is more or less nothing. I mean, you don't really feel it, do you? So where would you get to zero gravity? Because it's not, there's no true never pulling on you of anything, and the universe, well, all these tangents. Well, you couldn't even get far enough away from everything. The universe is expanding at an accelerating rate such that I think it's going to be, or it is, I don't know what the current thinking is, that the edge of the universe is expanding faster than the speed of light itself, because it's expanding into nothingness, so it can go faster than the speed of light. So you couldn't even get far enough away from everything to get to true zero gravity. But scientists kind of use a more of a mathematical approximation to get at, let's just say, escape velocity, for example. So escape velocity approximates how fast you would have to go such that you would never fall back into a gravity well, say the Earth. And for the Earth, it's 11.2 kilometers per second. And what that value really means is that you are going fast enough that by the time, that you will get, you will travel away from the Earth, and you will always be decelerating, but you will go out to infinity. You will always continue forward, and the gravitational pull on you will approach zero, but never quite get to zero. So you will approach your slowest possible speed, but never quite get there. So I don't think there is anything, there's no true zero gravity, like mathematical zero gravity. We say that as an abstraction because we're not used to an environment without any weight. So we say zero gravity, where microgravity, or something like an astronaut would say, is a lot more accurate. Oh. Could you tell that I had trouble with that one? I hope that's right. This equation is, that's a start. What's next? Got time
Last
for one
couple
more?
questions. Yeah,
Two more?
time for 2 questions.
Oh!
From Chris Rees. Hey Kyle, what substances could be used to make web fluid for Spider-Man?
Oh, so I'm not going to begin to speculate on what you could put in there, and this is going to sound kind of like a cheap answer, but carbon nanotubes. And I say that not because carbon nanotubes have just amazing properties, some of the highest tensile strengths and lowest weights, and they're absolutely amazing. Once we're able to make those bad boys in bulk, cool stuff will happen. But I say carbon nanotubes because I believe scientists have tried to introduce carbon nanotubes into the web fluid of actual spiders. And I don't know if they fed them small parts of it or they just introduced it in the silk somehow, but I remember reading the paper. And when they introduced the carbon nanotubes into the spider silk, it increased their strength quite a bit. So if Peter Parker was similarly smart, he's a science whiz, he could do something like that. You know, spider silk is already an amazing fluid, liquid material, so why not just use science to augment that by taking something like carbon nanotubes and mixing it together and shooting it through the spinnerets to make the material itself more of a metamaterial that is stronger as a whole. And so I would say start with carbon nanotubes or whatever the newest high strength material is, but carbon nanotubes would be a good start. I don't know what the rest of the formula would be. Last question?
Last question, real quick.
Oh,
From Alfred Garcia Franquero. Hey, Kyle.
sorry.
Yeah, I'm really sorry.
Yeah, sorry, man.
As a science educator, is it better to simplify an answer and lie, or tell the truth and risk not being understood?
Oh, well, I mean, as you can see here, I'm trying to be as accurate as possible. There's another science communicator friend who I like who says something like this, where you can simplify and not be completely accurate, but you can't be wrong. So you would never want to present an idea to someone that is factually inaccurate, that you know is false. But for the sake of communicating something to someone, you can use a metaphor or an analogy or something, like I always do, that approximates the truth, that gets very close while not being completely accurate. I think that is just how humans learn better. It's easier to tell stories when you can make abstract concepts like all of these fit within what we already think and what we already know. It's part of information theory. And so yes, I would say that for the sake of education, analogy and story, all of that is incredibly powerful and important. And you have to get as close to the truth as you can while noting any caveats. But do not tell someone a falsehood just to make it easier to understand. Because if you're lying to them, as you say, you're not really learning anything, are you? And we want people to be smart. Super nerds, if you will. And that's all the time we have for this episode of Because Science Live. Thank you so much for joining me for everything this week, not just the live stream, but also the main episodes and the vlogs. I read all of your comments that I can before I film those, so keep them coming. If you want more of me, you can go to facebook.com/becausescience or youtube.com/becausescience or @becausescience on Instagram and Twitter. You can suggest ideas to, I'm just fixing it. You can suggest ideas to me. Sometimes I do take them. I have a large list of topics. It just takes me a while to get through them. I hope you all have a wonderful rest of your weekend. Watch the One Punch Man video and share it with your friends if they like anime. They do. And be nice to each other, because, this is all we got.